And the main objective here to calibrate a two-element three-phase 3-wire induction wattmeter with reference standard wattmeter and stopwatch. So here given two element, okay. So you can already study here measurement of three-phase power. And there are three methods: single wattmeter method, 2-wattmeter method, and 3-wattmeter method. So here written in the object to calibrate a two-element three-phase 3-wire induction wattmeter. That's mean you can measure here the power with the help of 2-wattmeter. So 2-element is 2-wattmeter, right? But the main object here to calibration of a three-phase watt-hour meter. What is watt-hour meter? Basically, it's a energy meter. Do you have any problem? Just ask me. It's a energy meter, and this energy meter is basically induction type. This type of watt-hour meter or energy meter is used for in household purpose or in industrial purpose. Okay. So in this experiment, calibrate, it's a basically 360-degree rotating instrument. Mind it, it's a 360-degree rotating instrument. So another thing here, actually the scale of any meter, like as ammeter, voltmeter, or wattmeter, the total span of the scale here 120-degree. But in this type, basically three-phase watt-hour meter is rotating in a 360-degree. This is the main advantage here. So how can we calculate or calibrate the basically three-phase watt-hour meter? Just we have shown you another circuit diagram after this explanation. So in that case, you can measure the unit, per unit consumption of power. So in that case, we calibrate basically to measure the meter constant. For a particular meter, which you will given the meter constant, just we calculate in here the meter constant in different load condition as well as in different power factor. I think so in section B, electrical instrument, measuring instrument, Professor P. Kundu or Professor BJB? পড়িয়েছিলেন?
P. Kundu, sir.
P. Kundu, sir. So in that case, I think so induction type instrument already explained over here, and our target basically to calculate the meter constant also given here. So in how can you, the power factor is 50%, sorry, power factor is 0.5, or how can we the power factor is 1? Also explain you here to consider the basically load condition here. And another thing is meter constant also calculated in 0.5 power factor with 50 or 100% load and 50% load. Then another thing here, this is basically creep, just testing here the creep. Can you have said me what is creep? Anyone? Actually, without any load. Load mean here the current. Like as any transformer basically. And secondary said without any load. But there is a two coils, potential coil or pressure coil or voltage coil, another is current coil, right? So this current coil basically there is no load, the source open. But the pressure coil is here excited in around 110% of rated voltage. In that condition, we check whether the disc is rotating or not. If the disc is rotating, in that case, this type of machine or by this type of induction type instrument, there is a creep. The current coil here at the open, there is no load current, but the pressure coil, that is 110% of rated voltage, is checking here whether this is rotating or not. This is called creep. So the actual experiment explained here, or our one of the lab assistant, Mr. Deobrata Mondal. Okay, so I can hand it over to the Mr. Deobrata Mondal. After the experiment, you can ask me any question if you are interested. So, Mr. Deobrata Mondal, you can start here. Hello, Mr. Mondal. Okay.
Hello, am I audible now?
Sound is basically very low.
Okay, I am just running that video. You please watch it. Thank you. ভালো এটা অবশ্য অন আছে নেট তো আসছে আমি তো জানবো যেটা এখন কথা বলতে দেরি হয়ে যায়
Mr. Mondal, I think so you can stop the sharing. I can try here. Maybe there is a problem in downloading the video. হ্যালো, দেখা যাচ্ছে কি? Is it visible? Hello?
Yes, sir.
Okay.
Visible, sir. Yes.
Okay. Okay.
Yes, sir.
Okay. Mhm.
স্যার কিছু শোনা যাচ্ছে না।
হ্যাঁ, শোনা যাচ্ছে না কিছু?
না স্যার।
আমি তো শুনতে পাচ্ছি। কেসটা কি হলো তাহলে? Stop sharing. Okay.
Good morning, students. Today we are going to demonstrate the experiment of calibration of three-phase watt-hour meter using 2-watt meter. So we'll start from the power source. So you can see this is the three-phase variac. From here we are getting a three-phase supply, and this three-phase supply is connected to this MCCB. From this MCCB, this connection has gone to the three-phase transformer, step-down transformer. This one is, and you can see the rating of this transformer, that is 110 volt to 4 volt. From the secondary of this transformer, we are getting 4 volt output. That 4 volt is coming to this rheostat. Actually, this line actually exciting the current coil of the energy meter, three-phase energy meter. You can see this one is the three-phase energy meter induction type. Now you can see this is the circuit diagram. And previously whatever I said, that this is the step-down three-phase transformer. You can see the 4 voltage is coming from this the secondary part of this transformer. Okay, from there it is going to A, there is the ammeter, then R1. Okay, so this is the transformer. Okay. From there we connected it to the R1. It is in series, so I can connect it R1 first, then it can go to the ammeter. So we have connected it to the R1. From there it has gone to the ammeter. Actually, this is a combined meter. This one is the watt meter and voltmeter and ammeter also. Okay, it's a combined meter. So we connected it to this meter. So from here we can check the current. Now this meter is set in voltage. It is showing the voltage. Now if I change the mode, you can see the current. So this is the current now. So we connected it to the ammeter. You can consider it. So from the ammeter, it has gone to the wattmeter. So this is the wattmeter. Wattmeter is current coil. So it is already connected to the wattmeter. Okay, and from there a series line has gone to the second wattmeter. So you can see this is the second wattmeter. Here also it is connected. So physically when you see, this is the transformer. This transformer is this one. From here it is going to the R1. This one is R1. You can find it in your circuit. This is the R1. And this one is the W1. This is R2. This one is W2. Okay. And this is the our three-phase watt-hour meter. Actually in circuit, this is the three-phase watt-hour meter. You can see this is the three-phase watt-hour meter. This one is W1. This one is W2. R2, R1. Okay. And you can see this rotating of this watt-hour meter, and this one is the an important device. This is the phase shifter. Actually, we are not using here the load. Load means actually variable load. That means we are not using here any variable inductor or any variable capacitor by which we can change the phase angle of the circuit. We are only using R1 and R2. By changing this R1, R2, we will actually change the current value of this. These two resistances are resistive load only. So we are not here using any inductive load or variable capacitive load. By changing which load, we can change the phase angle. So here we are using phase shifter. Okay, phase shifter for phantom loading or fictitious loading. Okay, so by changing this phase shifter, we will change the phase angle of the circuit. Okay, now we are going to the experimental part. So there are total 3 runs. In run 1, at first we will do a short time test on unity power factor load. Okay, in this test actually we will make the power factor 1, that means unity power factor. In unity power factor, we will change the load to 100%. First reading will be on 100%, then it will be on 50%, then it will be on 20%. Accordingly, we will check total revolution time. Okay. In unity power factor, at 100% load, the first reading will be at 100% load. We will take the time for 40 revolutions of the disc. And then in 50% load, we will take 20 revolution time. We will take the time for 20 revolutions of the disc, and again in 20% of load, we will take the time for 10 revolution of the disc. Okay. Now run 1B, the second part of the run 1. First of all, of this run 1B, we will change the power factor, value of power factor. How? Already I told you, we'll make the value of power factor 0.5. Okay, by changing the phase shifter. Then in 0.5 power factor for 100% load, we'll take the time again, we'll take the time for 20 revolution of the disc, and in 50% of the load, we'll take the time for 10 revolution of the disc. So our run 1B is the short time test on 0.5 power factor. For 0.5 power factor load. Okay. Then next test is run 2. Run 2 will be the dial test at full load and unity power factor. Okay, and the third and the last test will be the run free, that is the creep test. Okay, now we will go to the to our experiment. We will see how we will perform this experiment. As I said, this meter is a combined meter. That means this one is W1 and as well V1 as well and I1 also. And this one is W2, V2 and I. So from these two meters we can see the value of V1 and V2. You can see the value of V1 is now 9 and V2 to set the time. Now we'll change the mode and set it ampere mode. Now it is ampere. You can see that current is changing. You can see now the 5 ampere current already set into ammeter. Okay, so total current is flowing through this energy meter and watt meter is 5 ampere. Now you can see the disc is rotating. So now our next step will be to make this power factor 1, that is unity power. As I told earlier that the phase shifter, we will use phase shifter, make the power factor 1 by varying the phase shifter. Now at first we are changing it to power mode for both the watt meter. Now you can see this is in power mode, watt, and this one is also. So how can I understand that it is in unity power factor? When it will be shown in 2 watt meters. The value of the watt meters will be same. Okay. So when now you can see that we are varying this watt meter, phase shifter. We are varying this phase shifter. So it is decreasing. This one is increasing. We will take it to the same value. Now you can see where changing it. Changing, you can see this now. This one is decreasing, this value is decreasing. We will make it same. We will make the value now you can see both the values are same. In this condition, you can say the power factor of the circuit is 1. It is in unity power factor. Okay. Now our setup is okay. So you can see these wheels are rotating. So whatever I said, it is good condition, will be the full load condition. That is 100% load. So it is in now full load. As I told earlier that for 100% load and in one unit power factor will take 40 revolutions of this disc. You can check only one disc. So how will you check that? You can see that a mark is there. So one mark will come back again here. So that will be 1 revolution. By that way, you have to count 40. And when you count that time, you have to start this stopwatch. So you have to start this stopwatch and wait for 40 revolutions. And then when 40 revolutions will be over, that time you have to stop this stopwatch and you have to take the reading. Okay, now we are starting. You can see this start. Yeah, is coming. Okay. Okay, start. already the stopwatch is working, and I am counting the distribution. Okay. So in 40 revolution, I got the time that is 102.4 second. Okay, in 40 revolution. So you have to note it down here, time taken in seconds, and also you have to note the wattmeter reading, that is W1 and W2. Okay, I'm just showing two values. So W1, W2, the number of distribution 40 we know already, and time taken, that is that 102.4, and calculator meter constant. All the formula has been given to your worksheet. From there you will get the calculated meter constant. Okay, and this one is the Kc. You have to calculate the value of Kc using this W1, W2, and T. When you are going to find the percentage of error, that time one value you need to know, that is the K. Kc we are calculating from here Kc, okay, but K, the value of K also you have to know, and the K, the rated, that is the rated meter constant of this meter. It is written on this cover of the meter. You can see that is 2400 revolution per kilowatt hour. Okay, so this is the value of K, and you also have to find out the percentage of error. Okay, now for 50% also same procedure that has to be done, the same procedure, but for 20 revolution, and for 20% load also you have to take the reading for 10 revolution. More or less same procedure for run 1B also, but before starting the run B procedure, we have to, you can see that the power factor is 0.5, so we have to make the power factor 0.5 by varying the phase shifter. Now we will vary the phase shifter. So here also how we know the when the power factor will reach to the 0.5. Okay, so now you can see when the total load will show in single wattmeter. In 1 wattmeter it will show 0, and the single wattmeter, the total load, it will show the total power, will show to the single wattmeter. Now you can see the value of W1 is decreasing. I am actually varying the phase shifter. Now you can see the value of W1 is decreasing, and the value of W2 is increasing. Now it is yes. Okay. Now total full power now showing in the W2. So this condition, the power factor is 0.5. Okay. So now we will start run 2. In run 2 you can see it is already written that just at full load, it is in full load. Okay. Now we actually get in full load, that is 5 ampere, already I have mentioned, and it will be again in unity power factor. So we again set it to 0 degree. That means unity power factor. You can see the wattmeter, both the wattmeter showing the same reading, more or less. Okay, let me set this. Okay, now you can see it's showing the same reading, so it is in unity power factor again. And in run 2, this is a long run procedure. Okay, So we will check the dial reading of this energy meter for 30 minutes. So we will run it for 30 minutes. So before we start the time counting, we will take the reading of this dial. Okay, this dial reading we note the reading, and after 30 minutes we'll note the reading again. So by taking this dial reading, we will find the total energy consumption in 30 minutes. Okay. Now, our last test is creep test. For creep test, we will de-energize the current coil. So we will switch off the power that is supply. We will switch off the supply of current coil. So only potential coil will be excited. There will be no supply to the current coil. You can see we already de-energized the current coil. So in that condition, the potential coils are energized only. In that condition, if the disc will rotate, we can say in the meter there is creep. But if disc will not rotate, so there is no creep in this meter. Is not rotating, both the discs are not rotating, so we can say that there is no creep at all. Okay. Thank you everyone. So I think you all understood the experiment procedure. We try to explain it properly. If you have any doubt, you please ask. Then we will try to explain you in better way. Thank you.
So, can we have any question? Hello? Hello? Hello?
Hello, sir.
Avib, you have any question?
স্যার বলছিলাম যে at certain load we are counting certain number of revolutions. What will happen if we observe more than that? Suppose for full load we are observing 40 revolutions. What will happen if we observe more than that?
In that case, there is no problem, okay? But we calculating here the basically meter constant. So the equation here, the basically meter constant like as number of revolution by first watt meter reading plus second watt meter reading divided by 1000 into time divided by 3600. Okay. So in that condition, we can get here the basically the value meter constant is 40 is normalized here, nothing else. Right way, we can calculate here the revolution here the basically like a 60 or 20. So in that case, in 40 case, it is shown here the more properly the meter constant, nothing else.
Okay, sir.
So I can share you another thing. This is basically this laboratory instruction sheet where they are given the Excel sample data calculation, right? So you can calculate any value. But in that case, another thing, the meter test reading, here is the duration is basically 30 minutes. Otherwise, we can calculate it here. Maybe it is 100, 1 hour or 2 hours. But this is basically factor is the time. For this reason, we just consider here the 30 minutes, nothing else. So after 30 minutes, in sample calculation, there is a change basically total energy consumed here to 0.2545 kilowatt hours. Very small. Okay. So I can share you the basically this sheet. And if there is any question, our laboratory technician is there. He can explain another way, practical way. There is no problem.
ল্যাব রিপোর্টটা কি স্যার সাবমিট করতে হবে তো, মানে কোনো টাইম?
ওটা আমি সেটা বলে দেবো অনলাইনে। ল্যাব রিপোর্ট সাবমিট করে তো আর লাভ কিছু নেই, সে তো তোমাদের 28 জন বা 30 জন একই রকমই করবে।
হ্যালো স্যার।
হ্যাঁ বলো
স্যার, বলছিলাম 0.5 পাওয়ার ফ্যাক্টর যেটা উনি দেখালেন স্যার, সেখানে প্রত্যেকটাতে দুটো করে একটা ডিসপ্লে ছিল। মানে প্রথমে যখন ইউনিটি পাওয়ার ফ্যাক্টর ছিল, দুটোতে রিডিং সেম আসছিল। দুটো ডিসপ্লে
বা তোমরা যদি মানে থিওরিটিক্যালি জিনিসটা দেখো, এটা হলো যে আমাদের দেখা গেছে যে এই 2 ওয়াট মিটার মেথডে মেজার করতে গেলে বা 3 ওয়াট মিটার মেথড দিয়ে মেজার করা হয়, সেক্ষেত্রে বেসিক্যালি 2 ওয়াট মিটার মেথডে মূলত মোস্ট পপুলার মেথড ইয়ার 2 ওয়াট মিটার মেথড। Power factor is dependent on the load basically, mind it. Power factor is dependent on the load. Is there in any power factor resistive circuit? What is the power factor in resistive circuit?
স্যার, পাওয়ার ফুললি রেজিস্টিভ হলো মানে তো স্যার ওখানে তো কোনো
লাইক অ্যাজ ধরো আমাদের ইন্ডাকট্যান্স, ল্যাগিং পাওয়ার ফ্যাক্টর, ক্যাপাসিট্যান্স, লিডিং পাওয়ার ফ্যাক্টর হয় এখানে। এখানে ক্যালকুলেশন করে দেখা গেছে এখানে যদি আমরা এই ওয়াট মিটারের ভ্যালু, if the watt meter value here the same, so the power factor here the unity. The watt meter value is the same, then power factor is unity. When the 1 watt meter value is positive, another watt meter value is 0. But in case in this experiment there is a tends to 0, right? যখনই 0 হবে বা একটা 1 হবে,
এটাই বলছিলাম।
হ্যাঁ, এটা টেন্স টু 0। এখন প্র্যাকটিক্যাল কেসে এটা টেন্স টু 0, 0 করা যায় না, তারপরে তো নেগেটিভ হয়ে যেত। সেক্ষেত্রে পাওয়ার ফ্যাক্টর অটোমেটিক আমাদের 0.5 হয়ে যায়। এবং তোমাদের যদি এটা বেসিক্যালি মানে আগে যে সিস্টেমটা ছিল, যখন এক্সপেরিমেন্ট করা হতো, পরীক্ষা যখন এক্সাম দেওয়া হতো এক্সপেরিমেন্টের উপরে, তোমাদের পার্টিকুলার একটা পাওয়ার ফ্যাক্টর ভ্যালু বলে দেওয়া হলো 0.75। সেই কন্ডিশনে তোমাদের মেজার করতে হবে ভ্যালুটা কত আসে। 0.75 যখনই বলছি আমি, in that case just so you can set the value of power of the 2 watt meter basically. ওই ইকুয়েশন থেকে তোমরা ওই পাওয়ার ফ্যাক্টর এসে 0.75 করতে গেলে অটোমেটিক তোমাদের ওই ওয়াট মিটারের ভ্যালুটা চেঞ্জ করে করে আমরা একটা কন্ডিশন আসবে, সেই কন্ডিশনে তখন পাওয়ার ফ্যাক্টর 0.75। ওকে, সেটা করা যায় এখানে। 0.5 যখন হচ্ছে তখন 1 watt meter value is 0, another is positive 1.
আচ্ছা স্যার,
ঠিক আছে। Wow, 39 আসো। এনি কোশ্চেন? আর যদি না থাকে তাহলে we can end of this session.
স্যার, এই ভিডিওটা একটু আমাদের দিয়ে দিতে পারবেন?
পেয়ে যাবে। আর এটা বোধহয় তোমাদের সেকশন B1 এ, সরি আমার তো বোধহয় B1, B2 তে কে আছে, কোন টিচার?
স্যার দেখতে হবে।
I think so, প্রফেসর কুন্ডু,
PhD স্যার।
যদি ডিএইচডি স্যার যদি ওটাকে আপলোড না করে, তার বিষয়তে তোমাদের এটা বোধহয় গুগল ক্লাসরুম আছে, তাই তো?
হ্যাঁ স্যার।
আমরা ডিএইচডি স্যার যদি আপলোড না করে তাহলে সেক্ষেত্রে আমাকে বলবে, আমি করে দেবো, পাঠিয়ে দেবো।
ওকে স্যার।
ওকে, so Vidit, we can leave for today.
ওকে স্যার।
Okay, thank you all of you.
Thank you, sir.
Thank you, sir.